Okay, number 2, what happens here? Well, if we plug in, we're looking at a limit here as x goes to 0. And if we plug in 0, we get, the limit as x goes to 0 of 1 minus 1 minus 0 over 0 minus 0, which is 0 over 0. So we can apply good old L'Hopital's. And if we apply L'Hopital's, the limit as x goes to 0, if we apply L'Hopital's, we get x, e to the x plus the sine of x minus 2 over 2x minus 2. And now we plug in 0 here, and if we do so, we get 1 plus 0 minus 2 over 0 minus 2. So we have negative 1 over negative 2, which is 1/2, which is C. A sign error would have gotten you to that one, choice A. So I bet that was a common mistake. All right, number 7. Let's see here. So this one is asking the position of a particle in the xy plane is given by this parametric equation. When is it at rest? Well, it is at rest, if the speed is 0, and if people try to find that, then that might have worked, though that gets a little tricky. But really, the speed is going to be 0 because speed is equal to dx dt squared plus dy dt squared, and we want this to be equal to 0. Well, this can only happen, since both of these are being squared, it can only happen if dx dt equals 0 and dy dt equals 0. Which kind of makes sense. If it's got no left-right direction and no up-down direction, it's going to be at rest. So if you find dx dt, you see that that is 3t squared minus 6t, which is 3t times t minus 2. So that happens at t equals 0 and t equals 2. So those are 2 candidates. And if we find dy dt, we'll see that that is 6t squared minus 6t minus 12, which is 6 times t squared minus t minus 2, which is 6 times t minus 2, t plus 1. So that happens at t equals 2 and at t equals negative 1. And so the only common time when both of them are 0 is at 2 only. So the answer to number 7 is C. Okay, so this one asks you to find the value of this series. And if you look at this and you're like, I have no idea, what I suggest you do in any series, if you want to try to figure out more about it, it sometimes helps to write out a few terms. And so if you start looking at this series, when n equals 1, you're going to get 2 squared over 3, also known as 4/3. When n equals 2, you're going to get 2 cubed over 3 squared, which is 8/9. And then we're going to have 2 to the 4th over 3 cubed, and so that's going to be 16/27. Well, you can see pretty quickly that this is a geometric series, where the first term, the sum of that's going to be the first term, which is 4/3, over 1 minus the multiplier, and the multiplier here each time is 2/3. So s is at 4/3 over 1/3, and that all comes out to 4. So the answer to number 10 should be C, and it is. Good. Okay, so this one here is a little tricky to figure out which one is which. And looking at this slope field, you have to notice a couple things. Well, one is that whenever x is 0, the slope is always 0, which kind of makes sense for every one of these answers. If x equals 0, dy dx is 0. Likewise, when y equals 0, every place where y equals 0 looks like it's straight up and down, so it's undefined. Well, that's what's y being on the denominator of every one of these differential equations tells you that that's true. Okay, so that confirms that these are all kind of candidates right now. We can't eliminate anything yet. Next thing you have to look at is symmetry. The slope here when x is negative, the slopes are always negative. When x is positive, the slopes are always positive. So that's going to allow us to eliminate a couple answers here. At this point, we can eliminate this guy, because this is going to be, when x equals 2 and x equals negative 2, this is going to have the exact same thing going on. Likewise with this 2 here. We can cancel that out. Let's see. Next. The what else can we cancel? Well, the y. There's not, is there y symmetry? When y equals 2 and negative 2, are things the exact same, or are they the opposite? And if we look here, it looks like the slopes are the same when y, like if you look at this y value here and this y value here, this x value is the same and the y value appears to have the same slope, which tells you that it can't be this guy. Because if this were the case, and it can't be this guy either, because if that were the case, then the y value here and here, the slope would have to be the opposite. But here the slopes are the same when the y values are opposite, so y must be being squared. So that deduces us right down to E. So it's key to look at, on a problem like this, to look at various symmetries and think about what changes. When the signs change, does the slope change? So look at kind of reflected points here and see what happened here, and reflected points here. That will be the key to doing a problem like this. All right, this is the problem that the most of you had trouble with. I think there were 11 of you that missed this problem out of the 24. So by far, this is the one that people had the most difficulty with. And the problem is here is, yeah, you have to find the equation of the line tangent at point C, and the point C is at negative 3 plus 8. And the tricky thing here is the t equals is not equal to negative 3, and t is not 8. So you got to find t first. So what we know is that the y value is 8. So what that would allow us to do is to write one equation, that 8 equals t cubed. So that's going to allow us that t equal, that says, well, if t is real, then t equals 2. And if you just double check that if I do x of 2 is going to be 4 minus 8 plus 1, which is negative 3, and sure enough, that's where that is there. Okay, so to find the slope, well, the slope dy dx is going to be dy dt over dx dt, but at the point t equals 3. And so dy dt is 3t squared, and dx dt is 2t minus 4. So evaluated at t equals 3, t equals 2. T equals 2 is going to give me 3 times 4 over 4 minus 4, which is 12 over 0, which is undefined. Aha! So if it's undefined, then the vertical line, it must be a vertical line going through that point, and the only vertical line going through that point is x equals negative 3. All right, let's see. Well, we've got to find g prime of 3, and we're given f here. Well, let's see. Let's take the derivative here. Oh, yes, this is a good old fundamental theorem of calculus problem using the Rawlinson method of solving this thing. So g of x is defined as the integral from 0 to 2x of f of t dt, which by the fundamental theorem is going to be big F of 2x minus big F of 0. So that means that g prime of x is going to equal 2 times f of 2x, little f of 2x, by the chain rule minus 0. And so that tells us that g prime of 3 is going to be 2 times f of 6. And if we look at f of 6 is negative 1, so it's going to be 2 times negative 1, which is negative 2, which is hopefully one of our choices. And it is choice C, which is the right answer. So yes, the chain rule is going to come into effect because this upper bound here is not just x, it's 2x. And so we have to keep that in mind. So I told you that the College Board likes to set that trap, and a lot of you guys fell into it. It is a problem that people tend to mess up with quite a bit. Only 24% of the people that took this exam got that right. Less than half of the people that got 5s. So you guys were way above the national average, and way above actually the percentage of people that got 5s average as well. So you guys did pretty well, but a few of you fell into that trap. I'm not sure what people did wrong on this one. So you're given the curve has slope 2x plus 3 at each point on the curve, which the following is an equation for the curve if it passes through the point 1, 2. Well, if it has a slope of 2x plus 3, they're basically just saying in words that y prime equals 2x plus 3, which tells us that y equals x squared plus 3x plus some constant. We know it goes through 1, 2, so we plug in the point 1, 2, and we get 2 plus 3 plus c. 2 equals 1 plus 3 plus c, which tells us that 2 equals 4 plus c, so c equals -2. So if we look at this equation here, and we let c be -2, well, there it is right there, point number D, or letter D. All right, so for number 20, the key is to look at this and think about what function this is. And it's one of the 3 functions that you're supposed to memorize. And what have they done to it? That's the question. It's a little confusing. But let's see if we can figure this out. Well, it looks like these, let's analyze this a little bit. So if it was sine or cosine, these would go up either by odd or even numbers. And they're not. They're going up by 1 every time, the factorials. So that tells us it's probably some sort of e to the x. And e to the x would be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. So what's going on here? Let's see. So it looks like each of these are also going up by 1. And each of these is 2 more than the ones below it. So it looks like they took e to the x and multiplied everything by x squared. Because x squared e to the x, that would give us x squared plus x cubed plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial plus x to the 6th over 4 factorial. Ooh, those are a bunch of the terms we want. Ooh, but we don't want these guys here. All right, well, let's subtract them away. So this is our choice right here. 20 is going to be D, because they took the x squared e to the x, and then they subtracted away the 2 terms that we don't want there anymore. And so that one is why that makes sense. All right, so this one's a bit tricky, because it's like, how do I go about doing it? Well, as n starts getting big, you kind of have to think about this one a little bit. It's not one that's obvious. It's not one that's screaming at you how to do it. But you can think about it a little bit, and you get this n over n to the p plus 1. And they want to know when this converges. So as n gets big, this 1's going to matter less and less. So this is going to be kind of similar to n over n to the p, which is going to simplify to 1 over n to the p minus 1. And this now comes down to a p-series test. If we looking at a p-series, and actually we'll hint that it's a p-series, is that they used p there. They could have used lots of variables there, but they used p there. So I think they're giving you kind of a little bit of a hint in putting the p there. And so once I've simplified it, it's like, when would this converge? Well, I need this exponent here to be bigger than 1. So p minus 1 would have to be bigger than 1, which means p would have to be bigger than 2, which is our answer, choice E. Yeah, if you try to do the ratio test on this, it will be inconclusive. That's the problem with p-series in general, is that the ratio test does not work. Love it. 24, the 3 for the price of 1 problems. So you have to solve all 3 correctly, or you don't get any credit at all. So let's look at each of these and try to figure out what works and what doesn't. Well, this one here, if you start writing out a few terms, it's going to be that thing to the first, which is 1, and then plus, and then you're going to have sine of 2 over pi to the first, plus that same thing, sine of 2 over pi squared, plus dot dot. Oh, it's a geometric series. So the question is, if it's a geometric series, is this less than 1? Well, I know sine of 2 is somewhere less than 1, and divided by pi, yes, that thing is definitely between 1 and negative 1. So this is a geometric series with the multiplier is less than 1, or between the absolute value of the multiplier is less than 1. So this one is a check, it converges. This is a p-series. This is 1 over n to the 1/3, and that 1/3 there is less than 1, so this, by a p-series test, does not converge. And this third one here, well, as n gets bigger and bigger, these numbers are going to get huge. This one's not going to matter much. So this is going to converge, this whole thing is going to converge to 1. So eventually we're just adding 1 plus 1 plus 1 plus 1 plus 1. So that is going to not converge, because eventually this is going to be similar to eventually adding up just 1. So, which of these diverge? Well, it looks like 2 and 3. So that should be D. And is it D? Yes, it is. All right, so this one, finding the coefficient of the x squared term in the Taylor series of 1 plus x squared about x equals 0. So there's two ways of doing it. One is to just kind of crank it out and say, okay, well, we've got f is equal to 1 over 1 plus x squared, which is the same thing as 1 plus x to the negative 2, and f prime will then be negative 2 times 1 plus x to the negative 3. F double prime is going to be 6 times 1 plus x to the negative 4. F triple prime is going to be negative 24. 1 plus x to the negative 5. Oh, but wait a minute, I don't have to go that far. This is what I need. For the x squared term, this is what I want to look at here. I'm doing it about x equals 0, so the x squared term in our Taylor series is going to be the second derivative taken at 0 over 2 factorial times x minus 0 to the second. So, well, this is going to be x squared, and then we're going to have the 2 factorial on the bottom, and if I plug in 0 to this, it's 6, and 6 over 2 factorial, so this is our coefficient, and 6 over 2 factorial is 3. So 28, the answer should be D, and it is. So that's one way of doing this problem. Another way of doing this problem is to realize that this could be obtained by rearranging and doing a little bit of work to the 1 over 1 minus x. So we do know that 1 over 1 minus x is equal to 1 plus x squared plus x cubed plus x to the 4th. And then what? Well, what I could do is I could differentiate this. And if I differentiate this, this becomes 1 over 1 minus x squared. And that's going to equal 0 plus 1 plus 2x plus 3x squared plus 4x cubed, and then all I have to do is replace x with negative x, and I get 1 plus x squared equals 0 plus 1 minus 2x plus 3x squared minus 4x cubed. And sure enough, there's my coefficient of the x squared term, and again, it's 3. So we could alter the geometric series to get that as well. All right, so for 82, you need your calculator for this one, and they tell you that the rate of change of the altitude of a hot air balloon from t equals 0 to t equals 8 is given by this function, r of t equals t cubed minus 4t squared plus 6. Well, if you graph this rate, and this is time versus the rate, which is the change in altitude from 0 to 8, you'll see that the graph does something like this. So 8 being out here somewhere. And the altitude is decreasing when r, the rate, is less than 0, so it's on this stretch right here. So this area right here would represent the displacement when it was going down. So we have to find these zeros. This 0 here is at 1.572, and that actually right there is enough almost to get us to our answer, because you'll notice that two of these have from 1.572 to some other number, both the same number, and sure enough this 0 here is 3.514. However, what do I want to integrate? Do I want to integrate r or r prime? Well, r is the rate. So this is already in, I don't know what the units are, assuming it's, I don't know if it's feet or meters, but anyway, that is the rate. You're given the rate of change, so you have to integrate that rate of change to find the distance. So choice A for 82 is the one we want. If you chose D, then you chose poorly. Because r prime, that will actually just give you, what will that give you? Well, if r was the rate, then this is almost the velocity, so that in the end, this will just be r of 3.514 minus r of 1.52, so that will give you actually just the change in the rate over that time. So that's not as useful. All right, so this one, we were given that f prime of some function f is equal to the sine of x cubed on the interval from negative 1.8 to 1.8. How many points of inflection does f have? Well, if you're given f prime, we probably think about points of inflection, we want to think about f double prime. And f double prime is going to equal 3x squared times the cosine of x cubed. And if you graph that, it's going to be a big mess. So what you want to do is make your window only go from negative 1.8 to 1.8. So you do have to change the window of your calculator to help you see this a little bit better. And when you do so, the graph is going to look something like this. So what's a point of inflection? Well, a point of inflection is where there's a change in concavity, not where the concavity is 0, because you could be like, oh, well, it's 0 a bunch of places. It's 0 here, 0 here, 0 here, 0 here, 0 here. So the answer is 5. And then you put 5 and you get it wrong, because the answer is not 5. The answer is 4. And that's because right here at 0, where it bounces, there's not a point of inflection there, because there's not a change in concavity there. Again, I've warned you guys many times that the College Board loves this little trick here, and to differentiate between point of inflections and the second derivative being 0. So there has to be a change in concavity for there to be a point of inflection, and that only happens 4 times in that interval. It does not happen at x equals 0, so the answer is 4, which is C. So 86 is C. All right, what's going on here? So you're given the graph of f prime, the derivative of a function f is shown above, and f of 0 equals 0, which of the following must be true? All right, so let's see. Let's think about what happened on f. If we're looking at f prime here, well, f increased a bit, and whatever the area of this is, f went up by, and then it went up, and then it slowed down how much it was going up by, but then it went up by even more, and then it went down a little bit. So, is f of 0 bigger than f of 1? That is not true, because we know that f was increasing on that stretch and increased by whatever that area was there. So this is not true. Is f of 2 bigger than f of 1? Yeah. So f of 1 had some value, and then f increased by that area. So this is true. And is f of 1 bigger than f of 3? Well, let's see. F of 1 was there. It went up by this area, and then it went down by this area. So is f of 1 bigger than f of 3? I don't think so, because this area is bigger than that one, so f of 3 would be bigger, so that's no good. So I think 2 is the only thing. 2 only, and is 92 only? Yeah, it is. Alright, so this is very similar, I believe, to the first problem on the medium-hard multiple choice packet that you guys had. So the height is given by this function. What is the height of the object when it reaches its maximum upward velocity? Okay, well this is, well let's say this is its height, so we can figure out its velocity by taking a derivative. So h prime is going to be its velocity, and that's going to be 24 plus 3 halves times 24 is 36, t to the 1 half minus 32t. And this is velocity, and if I want to figure out when it maximizes, well, I need to take another derivative. If I take another derivative, the 24 goes away. I get, let's see, 18 t to the negative 1 half minus 32. And if I want to find, well, this thing only find when this is 0, because that will be a critical value of the velocity. Minus 32, so 32 equals 18 t to the negative a half. So we can divide, let's see, what can we do here? We can rearrange this a little bit. This is 32 equals 18 over root t, which means that root t equals 18 over 32. And let's see, that's 9/16, which means that t is equal to 81 over 256. So, and then we have to find the height. So we have to take this t, which is 81 over 256, and plug that into our initial height function. And if we plug in 18 over 256 into this original function, we get 10.263, which is B. So h of 81 over 256 gives us that answer. And 91 is B, so there we go. All right, so for 92, let f be the function defined by x plus natural log of x. What is the value for which the instantaneous rate of change of f at x equals c is the same as the average rate of change over the closed interval 1 to 4? All right, well, if you graph this function, it's not the most exciting graph. It kind of looks like this. And so we're looking at from 1 to 4. Well, let's see, the average rate of change here, well, at x equals 1, that's at the point 1 comma 1, and x equals 4 is at the point 4 plus natural log of 4. So what is the average rate of change? Well, this is the slope of the secant line, which is hard to graph because this thing seems very linear, but it's not. So there is some value in between there where the slope is the average slope. So I think actually in reality this curve does a little bit like that. So somewhere along there there's the average velocity. Oh, this is the mean value theorem. So what is the average slope? Well, the average slope is going to be the slope of that secant, which is going to be 3 plus the natural log of 4 over 3. And so there must be some point in the interval where that is going to equal the slope of this. So what is f prime? F prime is 1 plus 1 over x. So at some point this has to equal 1 over 1 plus 1 over x. And if we solve this, well, we subtract 1 from both sides. That's going to give us the natural log of 4 over 3 equals 1 over x. So x must be 3 over the natural log of 4, which is equal to 2.616404. But we don't need to go that far because there's our answer. 92 is C. So it is a mean value theorem problem. Graphically, it's hard to think about it, but you are trying to find the average rate of change between two, so you want to find the secant line between those, and then you got to keep in mind that if the function is continuous and differentiable on the interval, which this guy is, then at some point along there, the slope is going to be the same. So that is the last of the multiple choice problems, and I hope these videos help people that don't get these lessons in class. All right, thanks.